Oh man. Hey, Professor. So this is actually my first video doing this. You could see me. Probably won't be able to see me. It's a little short. But we're going to be doing problem 6.2.6 today. Um, so the question asks to find the volume of the shape with bounds y equals x squared and x is equal to y squared. Um, and then that will be revolved around x equals negative 6. So this is the little graph here. Here's x equals to y squared, which is basically just y equals the square root of x. And then here's y equals x squared, basic parabola. And when you graph them, you can see that they intersect each other at 0, 0, and 1, 0. So that's our bounds for our definite integral. So the formula that we're going to be using today is the volume is equal to the definite integral of from a to b of pi times big Rx squared minus little Rx squared dx. So our big Rx squared is going to be x squared here, and our little Rx is going to be equal to um, x is equal to y squared, or y equals the square root of x, which is here. So it makes it pretty easy whenever you plug it in. So then when you get to actually plugging it in, you might be wondering where this 6 comes from. Well, the 6 is actually the bound that we got to revolve around here. So that's our radii. So you got to include that into the problem. So when you take a look at it, the volume is equal to the integral from 0 to 1 of pi times x squared minus 6 squared minus the square root of x minus 6 squared d of x. And so you kind of solve it out in the inside here, make it a little easier to see. So then we get integral from 0 to 1 is equal to pi times x to the fourth minus 12x squared minus x minus 12 times the square root of x d of x. And then so there, I kind of just simplified it, made it look nice and pretty. So it's x to the fourth minus 12x squared minus x plus 12, 12 square roots of x. And then so what we can do there is then we can start to evaluate it. So the volume is equal to the pi times x to the fifth over 5, evaluated from 0 to 1, minus 12 times x to the 3 over 3, evaluated from 0 to 1, minus x squared over 2, evaluated from 0 to 1, and plus 8x to the 3 halves, evaluated from 0 to 1. And you may wonder where that 3 halves comes from. That comes from doing the integral of the square root of x. Just raises the power, and the power over square root is a half, so 1 half plus 1 is 3 halves. There you go. And then whenever you simplify it, since you have to do it over 1 half plus 1, then that's 3 halves. So then 12 times 3 halves, you get 8. And so that's where that comes from. Whoa, I'm going to fall here. And so then whenever you go to solve it, you just evaluate these. So volume is equal to pi times 1 over 5, or 1/5, minus 4, minus 1 half, plus 8. And then you put it all over root, or all over 10, so that you can get a common denominator with all these guys. And so you're left with volume is equal to pi times 37 over 10. So, or pi times 3.7. You can do it that way too. But yeah, as a reflection, I really like doing this better, where I'm able to see the problem, write it down in my notebook, and then actually being able to handwrite it. It ends up making a whole lot more sense if you do it that way. So hopefully I'll be able to do this more, because this is really good. And in other terms, I probably should have used a different color. This blue kind of sucks. I should have used black so that it's easier to see. But other than that, I think that's pretty much it. So yeah, thanks for coming to my TED Talk. Have a great day, Professor.